Hi there. Thanks for joining us for Programmers Week. For those who may not know me, I'm Lawrence Smithmier, and I'm a practice lead consultant at Cognizant Softvision, where I work with clients to develop custom software and have been there for 9 years. I'm really excited to talk about tips and pitfalls that we've seen when moving to the cloud and encourage you to share your questions in the chat so that I can answer them accordingly. Without further anticipation, let's get started. So the real question that everyone is always asking is, how do I move to the cloud? And in order to really talk about that, first we need to understand what the cloud is. The cloud, a lot of times people say, is other people's computers. And that's what we thought about the cloud early, but that has changed recently. We're seeing a lot more vendors that give us the ability to run internal clouds and run clouds closer to home. So we can run cloud software on our own computer. So we need to kind of change the definition of what the cloud is before we think about even moving to it. So one of the things that I like to think about when I talk about the cloud is an infrastructure that I put my software in without worrying about what it's running on or worrying about the underlying infrastructure. So I don't have to worry, I don't have to be concerned about how many CPUs I have, how much RAM I have, or any of that. The cloud lets me abstract that away from the problem solving, which is what I really want to do. So with that said, let's get into how you should move to the cloud and some tips and tricks that hopefully will help you succeed in your endeavors. So quickly, a little bit about me. I'm Larry Smithmier, as I said. Here's my information. We'll have it available near the end as well. So this is a partial list of practices and tools that can ease cloud adoption. Okay, it's not a one-size-fits-all solution, because really, if I tried to give you one of those, you should be very wary. Everyone has a different organization. Everyone has different software that they're running, and everyone has a different problem that needs to be solved. So with that said, let's look at the first tip that I have for you. And this one is really straightforward and simple. When you move to the cloud, move just enough to the cloud, okay? Don't try to move everything to the cloud at one time. If you try to move everything at once, you're setting yourself up for failure. What you want to do is do an iterative process. So move just enough to add value and claim success, and then repeat the process. You don't build a brick wall by putting all of the bricks in a line and then standing the brick wall up. You build a brick wall one brick at a time, and that's what your cloud solution should be as well. You should think about breaking your problem down into smaller pieces and look at those applications that can most benefit from the move to the cloud. Okay. The next important part is chart your own path, because everyone is different. So you have to be the one that decides what pieces of your organization's software infrastructure need to move to the cloud. But the second part of this, with a local guide, is important. The map is not the territory, okay? You are special. Your organization has different software running than any other organization in the world. But you're special in sort of predictable ways. You're running an email system. You're running the application that does your finances. All of those applications are of a class. And if you find someone who's helped other organizations move to the cloud, they can help guide you and kind of avoid the pitfalls and traps that you otherwise might trip into and have to recover from. So chart your own path. Don't look at someone else's journey and measure yourself against them. But also take a local guide with you that can point out the benefits and not just the traps, but also the beauty and joy that you can get from having your software in the cloud. So the next is app migration is not portfolio migration. So I'm coming back to the same point over and over again, but when you migrate an application, it's not the same as migrating all of your applications. So you have a portfolio of software. You don't have to move it all, move small pieces. And when you move them, keep them connected where those connections are required through proxies, okay? So when you're moving your organization into the cloud, there are some pieces that just don't fit well in the cloud. The cloud is really good. Even an on-premise cloud, you're not going to have all of your applications go into it and work well. The cloud is built to scale horizontally. The cloud is built in such a way that you have an abstraction layer between all of the underlying compute power and your application. And some software just isn't written for that. One thing with the cloud we always want to look at doing is using the cloud infrastructure, the underlying functions that the cloud provide. By our software, we want to use that as much as possible. We don't want to do anything within our own software that the cloud already provides for us. Okay. And some applications, that's just not possible. So your applications are different. Migrating an application is not the same thing as migrating a portfolio. If you read online about portfolio migration, you should read those articles with one set of eyes and read articles about app migration or application migration with another set of eyes. They are different. Okay. The next thing is, as I mentioned, the cloud is meant to scale horizontally. Well, when you start your move to the cloud, don't start out with a singleton. Don't start out migrating your application into a single instance. And the reason for that is that there are things that are done as one person or as one application that when you add a second, some of the processes that you use change, and they change in ways that are not always apparent. But if you start out with two, adding a third is pretty much the same as adding the second, okay? So start out with a scale of at least two and be ready to scale up as your load demands. If you start out with one, adding the second one could find flaws that you would have found if you started out with two, okay? So don't start out with singletons. Start out with a scale not equal to one. Start out with two or three or four, and then test your application as it scales. One of the big things that trips people up a lot of times is when they go from a single application that's running on premise to a load balanced application that's running in the cloud, because they have session states that require sticky sessions, which is sort of defeating some of the purpose of having the cloud available. And that's a little technical. Sticky sessions just means that once you connect to a web server, all of your future interactions with the application will go to that same web server. So what that means is that you're kind of stuck with that one web server. Now, if that web server goes down, then your session is lost. If you build an application that does not require sticky sessions and can run under a load balancer, then the loss of any one of your web servers doesn't impact anyone other than slowing the system down a small amount. Okay, that's one of the reasons to start at a scale greater than one, is because you find out those little problem areas early so that you can fix them when you're building the software, rather than having to wait and come back in and do add-ons and make adjustments after you've already invested a lot in the migration. Speaking of migration, brownfield is not the same as greenfield. And these terms might be new to you, probably not, but let me just define them for us. Greenfield is an application where everything is new, all is possible. We're starting from scratch. Okay? A brownfield application is where we're taking existing functionality and we're re-implementing it in a new software program. Okay? Very few projects are really pure greenfield or brownfield. When we migrate, there's always the goal of just migrating what we have. We want to do a like replacement. We just want to take what we have now and move it into the cloud. However, we've all been in situations where, as we're moving, someone asks, while you're in there, there's this one thing that I need the software to do that it's not currently doing. Can you add that for me as you migrate it? And that turns us from a real brownfield into a little bit of a greenfield. We're having new functionality that we're adding as we migrate. Now, priorities and measures are not the same if you're doing a brownfield and a greenfield. So the hard part about kind of mixing the two is, if you're doing a brownfield migration where you're migrating an application without doing any additions or changes to the functionality, you ought to be able to set them side by side and do a comparison. And that's a real easy way to have a metric where you can test the load on your legacy application and test the load on your cloud application and see which one behaves better. We should see the cloud application be able to scale to much greater extent, but you don't know until you've measured. If you have a greenfield application, you don't have anything that you're looking to measure against in the background. Okay, so you need to come up with a different way of measuring your success when you have a greenfield application. And the way that you do that is you set expectations early, and you set your goals, and then you compare what you've delivered versus the goals that you had before you started the process. Okay, now the next one is a little controversial, not really. I really, though, believe personally that you should always, when going to the cloud, start out with infrastructure as code as part of your goal. That should be part of your deliverable. By infrastructure as code, what I mean is you should automate the environment, your cloud environment, as you're creating it. That means you do a test environment where you're, using the Azure portal or the Google Cloud or AWS. I'm an Azure fan myself, so I use the Azure portal, and I click create new, and I fill out all of the information on the website, and I get a new cloud resource. And that's okay when I'm testing. But when I'm actually implementing an enterprise solution, and I want to have it be a true cloud enterprise solution, then I should really not ever look at clicking a button on a web page to deploy or deliver any of that infrastructure. We should always go to infrastructure as code. We should always go to scripting the build of all of our environments. And one of the reasons for that, honestly, is so that our dev environment and our QA environment and our production environment all look the same. And at any point in time, we can tear them down and build them back up. One of the benefits of going to a cloud architecture is you get a lot of resilience, because the cloud itself allows you to not worry as much about disaster recovery because the underlying infrastructure itself has some recovery built in. But if we go with infrastructure as code and we make sure that all of the artifacts, all of the components that make up our application, our cloud application, come from source control, that means that anytime we can stand up a new, for example, demo environment. How many times have you been working and had someone say, I've got a new client that I want to show this to. Can you just stand me up a demo environment that they can play around in? And then at the end of the week, we'll kill it. If you've had to do all of this by hand, that's not something that you can do easily for them. If you started out, because most of your cloud applications are going to be greenfield or at least a brownfield into a new environment, because the environment in the cloud is brand new to you, you ought to be able to stand up a new version of that environment with really the click of a button or the running of a script. Okay? I can't emphasize this enough. Please, please look to infrastructure as code early. The next thing is that really you need to change your tempo. And this is more cultural than technology. So a lot of times when we're developing software, we tend to want to sit down and work on it until we're done, until we reach a state of bliss and have completed the entire piece of the problem, the solution to the entire piece of the problem that we're trying to solve at the time. Cloud requires, or should, in a good environment, should require a different tempo. And that means that we're deploying more often, and we deploy to all of our environments. We hear people talk about continuous delivery, and this is really what we want to do. So we, in most of the engagements that I'm a part of, we use a CI/CD pipeline, that's continuous integration, continuous deployment pipeline, that deploys to dev every time there's a code check-in. We'll talk about code check-ins in a little bit, but every time we do a code check-in, it deploys to dev. We let our QA set up a schedule that every day, at the end of our day or at the beginning of our work cycle, we deploy out to QA. And then once per sprint, we deploy out to UAT and possibly to prod. UAT, user acceptance testing environment. Okay? So your mileage may vary, depends on how many environments you have, but you really want to be deploying more often than you're normally doing. Now, the good news is, if you've been following along and you have your infrastructure as code and you've built out a CI/CD pipeline, then it shouldn't be that hard for you to deploy your software. It really should be just something that happens when you check in your code. And part of that, let me move to the next slide. One of the ways that we make that happen for us is we automate everything. So we automate deployment, we automate testing, we automate our documentation, we automate the environment creation, that's the infrastructure as code. We automate disaster recovery, and we test disaster recovery by failing our system. Okay? One of the things that the cloud gives us is the ability to scale up and bring up new environments at will, and then when we're done with them, delete them. It's a different mindset than the mindset that we might have had 10, 15 years ago when starting a new project. One of the first things I had to do was go to my manager and say, we need a new server. We're going to need 3 servers for each environment, because we want a web front end, we want a middle tier server, and then we're going to have a database server. And in fact, on the database server, let's go ahead and get 2 for our production environment, because I want to have them load balanced. Okay? Do you remember those days? you would put the order into Dell or HP or your vendor of choice. You would wait 6 weeks and the machines would come in, and then you would have to sit down and install your software. And you would install your software on dev, you would install your software again on QA, and you would install your software a third time into production. Each one of those was a manual process. And how many times have you had a problem that you're seeing in production, but you're not seeing in QA or dev? And you, after root cause analysis, come to find out there's a difference in the settings between those two environments because they weren't created automatically. They were done by a person. And I know that I keep run books, but sometimes I forget to write everything down, or I skip a step. And it's human nature. That's the reason that we have computers. Okay? So automate everything should be your mantra. The last thing, or not the last, excuse me, the next thing is you really need to change your development workflow. So we want to start kind of move left with our code quality. That means that we want to include tooling to ensure that the code that we're producing is of high quality. I mentioned the continuous integration and continuous deployment, our build pipelines. One of the things that we do, we add gates to our software pipelines. And the way that we do that is when someone checks in code, we set up a script that will automatically compare their code using tooling to a known set of failures, a known set of problems. SQL injection is the big one, and really all of the tooling that you could put in your pipeline will tell you about SQL injection. And it's really easy to find. It's really hard to remember sometimes to not do it. It doesn't take much to make an error that can cost your company a lot of money, a lot of time, and really a lot of prestige. So we as software developers need to put tooling in place to help us avoid those problems. Put those tools in our pipeline, but you can also add them to your IDE. So I'm a C# person. I've got friends that develop Java, and both of those environments, you have tooling that you can add to your IDE that will help you with your code quality. We can add linters, we can add static analysis tools. You can do that in TypeScript, in JavaScript, in Ruby, all of the different languages. Whatever language you're using, there will be a tool that you can add to your integrated development environment, your IDE, to make your life easier. Okay? Think of those as developer accelerators. And a developer accelerator is really a joy, because if you can save 10% of your time over the course of a multi-month project, you've really gained a lot. So I'm a big fan of those developer accelerators. Take a look at those. Now, the next thing, source control, Git wins. I don't think it's a surprise. Git is the source control that most people are using today. If you're not using Git, you really ought to look at changing to using it. You can self-host it. You can run it locally. It is a distributed model, which means that there is no central single authority that contains the source control. But now that we know that Git is the source control that we're going to be using, what branching strategy are you going to use? And let me tell you, on this, like all of the other things, I'm a consultant. I say it depends a lot. In this case, it really depends. It depends on your team size. It depends on the maturity of your team. On most of the projects that I'm working on, we use a variety of branching strategies that are based off of Git flow, where we have a main branch, a development branch, and then feature branches that branch off of the development. That's what we do. I tend to work with fairly large teams. That's overkill if you have 2 developers. If you just have 2 developers, you can do main branching, where you branch your features directly off of main. The big thing that should inform your branching strategy is how many developers you have and how active they are in developing, and how much kind of cohesion you have between those features that they're developing. Branching is used in order to improve your ability to merge changes into the software that you're deploying out. Okay, so think about it before you get started. It's really not fun to change branching strategies once you've been coding for a little while. So think about it. Again, talk to your local guide and reason together about what the correct branching strategy for your team and your situation should be. Now, containers. If I talk about Kubernetes and Docker and containers, everyone kind of has an idea what I'm talking about, but understand that they are a buzzword, they are a big thing, but they are a means, not an end of itself, okay? They solve some problems, but they also introduce other problems. So be wary if someone comes in without asking you anything about the problem you're trying to solve or the solution that you've envisioned and are planning on developing, and immediately tell you that you need containers. Okay. They're not a panacea. They're not for everyone. They're not for every project. Where appropriate, they are wonderful tools. Don't just, use your hammer of containers on every project you have. And one of the reasons that I say that is because I like to talk about platform as a service, PaaS, software as a service, and infrastructure as a service. Okay? Those are really, when we're moving to the cloud, those are the terms that we should have in our head. And a service, really, when it says as a service here, it just means that we're giving up control, but it also means that we're giving up responsibility for certain aspects of our environment. So my goal is to have as little responsibility as possible. But that's kind of offset or balanced by my desire for control, because there's certain things that I need in order to implement the solution that I've envisioned. There's a certain amount of control that I have, or that I require. So I like to go with software as a service where at all possible. In other words, use a cloud database rather than installing, standing up a VM and installing SQL Server or PostgreSQL in that VM. That VM would be infrastructure as a service. And if you stand up a virtual machine, you have to keep it patched, you have to keep it secure, you have to do all of that, as well as maintain the software that you've installed on it. Whereas if you deploy a PostgreSQL database in AWS, all you have to do is worry about the schema. All you have to do is worry about the amount of data that you have and the throughput that you need. So give up whatever control you can so that you also give up that level of responsibility. And the last thing that I want to talk about as far as the tip and trick is really to join a community. And you've already started that path by joining us here at Programmers Week. So you don't have to know everything. You don't have to do everything yourself. What you really need to do is have a group of peers, a group of friends, a group of colleagues that you can leverage to get these things, to help you really through that journey to the cloud. Okay. Now, You've all heard about 12-factor apps, and really 12-factor apps are kind of they're sort of they're sort of table stakes now, okay? There's a lot that's good about them, but when I think about 12-factor apps, I think that there's a lot that it's not always applicable to what I need. Some of the pieces are really good for certain types of applications, but I just don't necessarily feel that I need them. And so I've been kind of thinking about a fine 9, okay? 12's too many. I don't have 12 fingers. Let me do 10. Well, I'm going to keep one in reserve. Let's do 9 different things that we can do to build ourselves a better cloud experience, to move our software to the cloud. Okay. So we're going to start out with better code. And the way that we do that, number 1 of the fine 9 is we need to take our configuration and our secrets and centralize them. And there's a lot of parallels between the 12-factor. I'm building on the shoulders of giants. I don't claim this as, something that's been handed down to me from above, but we really want to have in all of our environments a single binary artifact, a single compiled piece of code that goes and works in all of our environments. The reason we want that is so that if there is a problem in production, we can know that we're running the same code in test, where we can try to replicate the problem and get to a solution. You don't want to be debugging. You really, really don't want to be debugging in production, okay? Step number 2 is observability. And one of the ways that we're able to ensure that we can build our in our test environment, we can replicate a problem, is because we've added this observability. Logging is more than just capture, okay? Data is not the same as information. When you're bringing this information in, when you're bringing in these logs, when your application is telling or exposing its inner workings, it should expose it in such a way that we can use it to reason. So make sure that your application is not just spewing out logs. Make sure that your application is observable, that we can observe its inner workings. Next, number 3 is you really need to look at having some type of evolutionary database design. Everybody stores data. You don't always model the data that you're storing the right way when you start. Also, we live in a changing world. The data that you need to store might change. That means that you are going to need to evolve the schema of your database. Starting out with that in mind, build your database schema in such a way that it can easily be versioned and transitioned. Okay. Number 4 goes along with this. Build and create a golden data set. Build a data set that you can use to test out your schema, that you can use in your test environment, so that you don't have, so that when you stand up the demo environment that your salespeople ask you to stand up, you don't have to spend all weekend entering in data before the software can actually run. You want your deployment of the new environment, the infrastructure, the code, and the data to all be automated. So build out a golden data set. I'll tell you, it's a lot easier to do at the beginning than it is to at the end. Trying to kind of retroactively build this golden data set is not something that is for the faint of heart. Don't try it at home, please. Okay, next, test just enough. So this is one of those it just depends things. We don't want to hit 100% code coverage. Really, any metric that you put, if I say I want 60% code coverage, I'll tell you that that's a number that I just pulled up, and it's not based in data, and it really depends on the software that I'm testing. but you ought to automate your tests, and you ought to automate enough tests to cover what you need to test on your program. Okay. One thing, a good rule of thumb is anytime you have a bug, write a test for that bug and then implement the solution that makes that bug go away so that the test passes. That's the minimum that you should do. All right. Next, analyze everything. Now, this goes back to using our tooling. So we want to do static analysis. We want to use linters. We want to measure the cyclomatic complexity. That is, how much cohesion is there between the different pieces of our code? How complex are the objects and the functions that we have within our code? Because the more complex it is, the more testing we need to have on it. Okay, so analyze everything. It will lead you to all of these other things. Next is more really business than technical, but you should align the ownership and responsibility of your interfaces with the teams that are developing those interfaces. If you have a web service, for example, that has two owners, that have two teams that are working on them, there will be friction, not necessarily mean friction, but there's just communication that has to happen between the two teams and coordination. And if you can avoid that by changing your architecture just a little bit, you'll be able to take all of the energy that was used in that communication and use it to develop new features. Speaking of interfaces, number 8 is version your interfaces. You need to really be able to run 2 versions of the same web service side by side and have your application hit one or the other or both. Okay? You need to be able to version your interfaces. And the last thing is deploy separately from day one. It's always convenient to deploy all of your software at one time, but if on day one you start that because it's convenient, then by the end of week 18, it's the only way you're able to deploy your software. Okay, so deploying your software separately allows you to test that your versions on your interfaces are working correctly. It allows you to test that the schema changes that you're making to the database aren't breaking something else, some unintended consequences of a particular piece being deployed. Okay? If you don't test it, then you're not really going to be able to tell if those things are there. So deploying separately is my big one. It's the easiest one to forget to do. It's also the one I think that will come back and bite you the hardest if you don't get it done early, because I've been on projects where the only way we could deploy was deploy everything, and those are not fun. So a couple of closing thoughts, and then we'll get to questions if there are any. Peter Drucker said, measure, measure, measure. You cannot manage what you do not measure. Okay? Now, as a consultant, I also want to document. You as people who are working in the software industry, you need to document everything that you do. You can't prove what you do not document. It's not by Peter Drucker. This is a kind of a Larry thing here. You need to document what the system does. You need to document what the system was doing before you started working on it. You need to document who asked you to make the changes that you're making to the software. You need to document everything. Okay? It's a lot easier to document it as you're doing it than it is to come back and fill in the documentation at the end. So that's my final words. I do want to thank you for your time. Let's see if we have any questions. I'll put up the slide that has my contact information, and we'll see what's up.
Hi, Larry. There are no questions in the chat right now, but several rounds of applause.
Oh,
so you must have done a great job explaining everything.
Well, I've enjoyed it, and please feel free to reach out to me or any of our teams. We would love to talk to you about not just the software that we build, but the reasons that we build it and why we enjoy it. So thanks, everyone.